Hi, my name is Natasha. For my presentation, I chose scenario 1, fare analysis by region and time of day. So now I will walk you through the requirements. So firstly, I read the CSV by loading the dataset using the built-in open bracket plus readlines bracket. Secondly, I accepted the user filter vehicle underscore type by inputting it with a validation loop. Thirdly, I formatted a table that compares peak versus off-peak fares per region across all five different vehicle types. Fourth, I coded a conclusion using insight generated from data. And for the fifth, I ensured that there's a continuous loop up until the user decides to exit by entering a blank code. So this is my overall program flow. Firstly, it reads the CSV by finding column positions via find underscore column bracket, while the true loop asks user for what vehicle type they're looking for. So then each loop will call compute underscore averages bracket, and then it will print underscore table, and finally it will print the analytics and the conclusion. A blank input will exit the loop, and it will immediately print the value add and the summary print table. So in the case of some key parts of my code, for case 1 reading the CSV file, I ensured that the CSV is read by using only the built-in open bracket and read lines bracket. And over here in case 2, it shows how each line is split by a comma to produce a list of field values. Get underscore hour bracket will extract the hour by splitting the datetime string on the space. And then the colon is underscore peak underscore hour bracket will return true. For example, if the hour does fall in the peak time of 7 to 8 am or 5 to 8 pm, it will return true, or if not, it will return as false. So my second example of a key code is compute underscore averages. As can be seen over here, it uses a dictionary called region underscore data, which will store a running total and count per region. So for every row that matches the chosen vehicle type in the filter, it will convert the fare to a float called get underscore hour and is underscore peak underscore hour, and then it will add the fare to either the peak or the off peak for the region, and it will also increment the corresponding count. Rows not matching the vehicle type filter will also be skipped using the continue. For my next example of key code, this shows how I formatted the table. For the no tabulate module, I built it using entirely f-string alignment operators. For example, the less than sign will left align the text, the caret sign will center it, and the more than sign will align the numbers to the right. For example, I also put a full stop 2f will format all fare values to two decimal places automatically, and I stored the column widths as variables so all the rows will be scaled consistently. So this is the actual console output when I type, for example, the premier vehicle type. So the table will show the average fare between peak hours and off-peak hours, and you can also see information at the bottom as the analytics conclusion, such as, for example, North has the highest peak fare at $10.85, and comparing which peak fares is higher than off-peak by, for example, $0.14, and showing how Premier is the most expensive vehicle type overall. And then this is what happens when I want to end my code, which will automatically print the value add analysis and the final summary. Both sections will run automatically after the loop exits without any extra code being needed. It will value add all five regions by percentage fare gap between peak and off-peak and rank them. So this compares all four vehicle types, showing that Premier has the highest peak fare at $10.55, with North having the largest gap at 1.9% with highest search pricing. That is my presentation. Thank you.